Today we're going to talk about file and folder access permissions. When we talk about access permissions for a Unix or a Linux system, there are two basic types of access permissions we can be talking about. We can talk about the traditional access permissions, or we can talk about access control lists. We're going to focus on the traditional access permissions because this is something that's going to be in use in any Unix or Linux system that you look at. The access control lists are used by some, but not all. There is some information in your book about them if you'd like to read about it a little bit more deeply. It's good to know that they exist. We are not going to cover that in this class. Page 98 in your book does cover some of the access control list and traditional file permissions, the information about our permissions. So if you want an extra source to look at after listening to this talk or watching this video, then feel free to take a look at that. So with that said, we're going to start our script file. So I'm going to type script video 4, hit enter, and then we're going to take a look at the files in our current folder. If you remember correctly, ls would be the command that would show us the files and folders in our current directory. Again, your list is going to look a little bit different than mine. If we type ls all by itself, it just shows us the names of the files and folders. We want to see a bit more information, so we want to see the long list. So ls space -l and hit enter. And this gives us a bit of information. We looked last time at seeing the last edited date and how we could change that with the touch command. We also have noted that it shows us the size of any given file. But we've kind of glossed over this first part at the beginning that shows us a list of permissions. And so that's what the first part of this file listing, the part that on mine, that first line says D RWX R-X R-X, period. And that's the information that is actually tells us about permissions. So the first character in that permissions group is either a D or a dash. The D means that it's a directory, the dash means that it's a regular file. And then we have three different groupings there. The traditional file permissions in Unix are divided up into three different groups of either the user, the group, or other. And each of those can have possibly three different permissions: read, write, and execute. So we have a total of 9 different permissions that can be either set or unset. So if you look at the file that says go.txt on my screen, you'll notice that for the user has read and write permissions, the group has read permissions, and other has read permissions. And you know who the user and the group assigned to this particular file are based on the names in the third and fourth columns. So for me, it says Jeremy is the user that owns this file, and faculty is the group that owns this file. If you've still got this file in your home directory, it probably has your own username and group that you're assigned to, your default group as your as the owner and the group owner. So when we're working with Unix file permissions, read on a typical file means exactly what it sounds like. It means that I can read the file. Write means that I can actually make changes to it. And X means that I can execute the file. This is used for script files, programs of some sort. I need to be able to execute them in order to be able to run them. In fact, if I looked at ls-l of /user/usr/bin, you'll notice that for these files, root is the owner and root is the group, so we can't go ahead and that's who owns the file, and we don't have write permissions. But you'll notice that everybody has execute permissions. So these different programs that we run, like we run who or which or ls or whatever, these different little programs that we run are actually, we have permissions that are associated with those that tell us that, hey, these are programs that we can actually execute. I was scrolling through to see if I could quickly find one that we've already used that's here in the /user/bin, but I didn't see anything. But you'll do notice that these files do have permissions for read, write, and execute for the user, read and execute for the other, or for the group, and read and execute for other. So I'm going to list the files in my own directory again. So again, read, write, execute for user, group, and other are our traditional file permissions. Very often we'll need to change these permissions. So I'm going to look at that go.txt file, and I'm going to use the chmod command. So the chmod, C-H-M-O-D, is the command that changes our access permissions. And so there's two different ways we can do this. The first one is that I'm going to show you is a symbolic way. And so remember I said we have user, group, and other. So in this case I'm going to say u minus w space go.txt. So what this is going to do is chmod space, I could do u, g, or o to change a particular, to say a particular one of those user, group, or other, minus to take away a permission, or plus to add a permission. And w says this is the permission that I want to add or take away in this case. So if I do chmod u minus w go.txt, when I ls-l again, you'll notice that I no longer have the ability to edit go.txt. In fact, if I type touch go.txt, it'll still let me change those meta permissions about it. But if I say vim go.txt, you don't have to follow along with this particular command in your script file. But when I look down at the very bottom here, it's telling me that the file is read-only. And if I try to write, it tells me that the read-only option is set, and it won't let me write. So I'm going to go ahead and quit this with Q:*Q! If you did happen to open that up, type :Q! To exit Vim. So I've made it so that that file is I only have read access to it, not write. I could also say chmod u equals w go.txt. And now if I use the equals instead of the minus or the plus, I'm setting for my user, I'm saying I want it to be exactly w is the permission that I want to give it. So now I have write access to go.txt, but I don't have read access to go.txt. In fact, if I type cat go.txt, it will now tell me permission denied. I can no longer display this file to the screen because I do not have read access. So I'm going to chmod u plus r go.txt. I now have read access to it once again. And what I've done there with u, I could do the same thing with the group or the other. I'm only allowed to do that on files that I actually have ownership of, so I can't change the permissions on just any file on the system. I can do that on files that I have ownership of. The other way that we can change permissions is with an absolute change. For the absolute permission change, it helps to understand a little bit of binary. So I'm going to type some stuff on the screen. I'm not going to hit enter after any of these. You don't have to follow along with this particular portion. I'm just going to show you some quick binary counting. So in binary, 0, 0, 1 is still 1. The lowest significant place is either 0 or 1. If I change this to a 1 and this to a 0. So if I have 0, 1, 0 in binary, my second place over from the right is the 2's place. So this would represent 2. This would represent 4. This would be 4 plus 2, so it would be 6. And this would be 4 plus 2 plus 1, so it would be 7. So my last one that I have here is 1, 1, 1. You can find other tutorials for counting in binary, but it helps to understand that. In that if I say chmod 777 go.txt and hit enter, ls-l, you'll notice that all the permissions are set now. I have read, write, and execute for both for user and group and other. What I'm doing is saying, if I think of that R, W, and X each as a 1 or a 0, I'm saying I want 1, 1, 1 for the user, 1, 1, 1 for the group, and 1, 1, 1 for the other. And so if I want to change it back to the way that it was, I could do chmod 644 go.txt, and now I am back to read, write for the owner, only read for the group, and read for the other. Read, write for the owner, read for the group, read for the other. So that's the rundown of using chmod. Another command that is relevant to dealing with permissions here is chown. And in this case, what chown does is changes who owns the file. So if I wanted to change the ownership of go.txt, I would just type chown, the name of the person that I want to give the ownership to, and then space the file that I want to change. In this case, we're not going to execute this command just because you don't have any other users that you can give the permission to. But if I didn't own the file currently, I could say chown space Jeremy space go.txt, and that would assign me to the to own the file. That's the same basic idea. One more permissions level thing that we want to take a look at is a command called umask. Umask shows us what the default permissions are. So when we create a new file using, say, the touch command, then it has a default set of permissions. Umask is a little bit weird in that it is exactly the opposite of how you would expect it to. We're going to ignore that first 0 for now. Just look at the last 3. And what this tells me is that if I create a new file, the permissions that are not allowed to the owner are simply none. That the owner will have all permissions. The 2 tells us that the group will not have that middle column of permissions. Remember, the middle column is the 2's groups. So we have, and the group will have read and execute permissions, but not write permissions. Same thing for others. By default, when we create files, they're not going to have write permissions. This is complicated a little bit by the fact that a lot of our commands, such as touch, assume that we don't want to create things with execute. Even though the umask would allow us to create it with execute permissions, it's not going to do that. So if I say touch example, and then ls-l example, I'm going to have read and write, for the owner, read for the group, and read for other, because the UMask says do not give write permissions to the group or the other. If I change my UMask to be, say, 077, and now I say touch example 2, ls space dash l example 2. When I set my UMask to 077, I'm saying, hey, give the user all the permissions he wants, but don't give any permissions at all to the group or the other when I create a new file. And you'll see that's exactly what we have. I have read-write permissions for the user. I have no permissions for the group and no permissions for the other. So the UMask sets up what permissions do we not want to give to our different groups. If I use UMask space dash capital S, it's going to show me what it means. So it's going to say this is the symbolic representation of it. So it's going to say the user will get read, write, and execute. The group will get nothing. The others will get nothing. And so UMask space dash S is a good way. If you're not sure, if you're a little bit fuzzy, you can't remember what all those numbers mean, that's a way to be able to see what it means. I'm going to clear the screen, ls-l one more time, and I want to point out the fact that our directories also have permissions. So when we are talking about permissions with directories, they obviously don't mean exactly the same thing as they do with a file. What does it mean to write or execute a directory? But we can kind of figure out what it means. Read, if we have read access to a directory, it means that we can list the contents of that directory. If we have write access to a directory, we can actually change the contents. Sorry, I may have skipped out just a second there. We can change the contents of that directory if we have write access. The execute's a little bit less obvious as far as what that means. And what the execute permission on a directory means is that we have permission to enter that directory. So we can use cd to change that into our default directory. So keep that in mind when you're working with directories or with files. This is the basics of our of what permissions are in a traditional Unix file system. We're going to stop the talk for here. I'm going to clear the screen, and then I'm going to exit my script file. And be sure to let me know if you have any questions.